Hello, everyone. In Chapter 2, we learned about the cryptographic foundations of blockchain. Today, we will introduce Chapter 3, the network protocols of blockchain. This chapter mainly consists of three parts. The first part is an overview of P2P networks. The second part discusses the types of nodes in a blockchain P2P network. And the third part covers the P2P network protocols in blockchain. In this lesson, we will cover the content of the first section, an overview of P2P networks. P2P stands for peer-to-peer, which can be directly translated as point-to-point. A P2P network is a typical autonomously executed computer network composed of computers with equal status that can provide certain services. It is also a distributed computing model or network system based on the internet. Additionally, P2P networks are often referred to as overlay networks, peer computing, or peer-to-peer network systems. Each computational entity is collectively called a peer, which can be a program, computer, digital device, etc. Moreover, in specific contexts, they can act both as clients and servers. Currently, there is no unified definition of P2P networks. To reflect the characteristics of P2P, some representative IT companies and researchers have provided various definitions of P2P networks. For instance, some believe that P2P is a technology for sharing computer resources and services through direct exchange between computer systems. Others consider P2P as a system composed of several interconnected computers working collaboratively with the following features. First, the system relies on the collaborative work of edge devices, allowing each computer member to benefit directly from other computer members rather than from a central server. Second, members in the system play both the roles of servers and clients simultaneously. Third, users in the system are aware of each other's existence, forming a virtual or actual community. Additionally, some view P2P as a network structure where each node has equal capabilities and responsibilities. The network structure in peer-to-peer, P2P networks is completely different from that in client-server, CS, structures. Typically, in CS architecture, one or more central servers provide services to other clients. P2P networks facilitate real-time data and information transmission between nodes, allowing each node to act both as a client and a server. Additionally, each node is autonomous and capable of maintaining connections with nodes that may experience interruptions or lack fixed IP addresses. Therefore, from the above definitions, we can see commonalities in the descriptions of P2P networks, such as resource sharing, autonomy decentralization, and dual identity in CS roles. These all reflect some fundamental characteristics of P2P. Combining the existing features of P2P networks, our course defines a P2P network as follows. First, a network G is built on top of the internet and satisfies the basic characteristics of the internet. Second, within network G, there are two fundamental behavior modes, one defined as P, which represents the act of producing resources, and the other defined as C, which represents the act of consuming resources. Third, all nodes in network G have a peer relationship and possess both behaviors P and C simultaneously. Fourth, peers in network G exchange with each other directly and equally in a bidirectional manner to perform functions P and C. Fifth, network G relies on the existence of peers, and peers can freely join or leave. Sixth, when any peer joins or leaves, network G still maintains its organizational and structural characteristics unchanged. Additionally, in some literature, P2P networks are also referred to as overlay networks, meaning that P2P is a logical network built on top of a communication subnet. A P2P network established based on the TCP IP protocol sits above the network interface layer of the TCP IP protocol stack and primarily includes the application layer, transport layer, and network layer of the TCP IP protocol. It is a logical network that is higher than the physical network. Its topology will not exactly match the topology of the physical network. The TCP IP protocol stack generally consists of 4 layers: the network interface layer, network layer, transport layer, and application layer. Let's summarize the characteristics of P2P networks. Comparing the traditional client-server (CS) model with the peer-to-peer P2P model, we can summarize the characteristics of P2P networks as follows. They have distribution, dynamic topology, network robustness, load balancing, cost-effectiveness, and privacy. Currently, based on the relationship of P2P network topology structures, P2P network topologies can be divided into 4 types: centralized topology, fully distributed structured topology, fully distributed unstructured topology, and hybrid topology. Among them, centralized P2P networks are also known as first-generation P2P networks. Fully distributed P2P networks are referred to as second-generation P2P networks, and hybrid P2P networks are known as third-generation P2P networks. Let's understand the centralized P2P structure. The centralized P2P network structure, also known as a centralized P2P network architecture, is based on a centrally controlled network architecture, similar to an abstract star network topology. In the centralized P2P network topology, the index directory server at the center connects in a star-like fashion with each directory server client, but this connection is not a physical star topology. Instead, it forms a virtual star structure based on the centralized P2P network topology protocol. In contrast, the fully distributed structured P2P network topology has no central server. Each node can freely join the network and form a logical overlay network by connecting peer-to-peer with a set of neighboring nodes. However, under these circumstances, organizing nodes within the network and reducing the broadcast storm of network routing messages caused by nodes being unable to access resources owned by other nodes becomes an urgent problem to solve. Fully distributed structured P2P networks address this issue by using a distributed hash table approach. Unlike fully distributed structured P2P networks, which have strict limitations on information location, fully distributed unstructured P2P networks do not impose strict limitations on information location. In fully distributed unstructured topology P2P networks, a random graph organization method is adopted within the overlay network, where the degree of nodes follows the power law distribution. This allows for faster discovery of target nodes and demonstrates good fault tolerance in response to dynamic changes in the network, thus providing good usability. Alright, that brings us to the end of the first session today.